Hi everyone. Today's goal is solving linear systems by graphing. A system of linear equations, or a linear system, is a group of linear equations with two variables. A solution to a system of equations is an ordered pair that makes both equations true. Find the solution of the system of equations by graphing. By now you have a number of different ways that you can graph. These are in slope-intercept form, so that would probably be the easiest way for you to do it. Sketch out or use graph paper and graph out y equals 6x and then y equals 2x plus 4. Your graph should look like this, and the solution to the system is the point where both of these lines cross. In this case, our coordinates here would be 1 for the x, and then 1, 2, 3, 4, 5, 6, 6 for the y. So your solution would be 1, 6. In order to check to see that we graphed it correctly, you're going to substitute in 1 for x and 6 for y, and see if it makes these equations true. 1 times 6 is 6, so it works on our first one. 1 times 2 is 2 plus 4 also equals 6. So 1, 6 is the solution to this system of equations. Here's another example. Y equals 3x minus 4, and y equals negative 3x plus 2. Again, stop the tape, take a few moments, graph both of these equations, and see the point where they cross. Your graph should look something like this. The intersecting point of the two equation lines is 1, negative 1. In order to see if it works, plug those numbers or those values in for x and y and see that both these equations are true. 3 times 1 minus 4 is in fact negative 1. Negative 3 times 1 is negative 3 plus 2, which also equals negative 1. So we've graphed them correctly and solved the solution. Here's another example. Y equals 4x minus 1, and y equals negative x plus 4. Again, stop the tape, draw the graphs, see what you get, and then come back and see if it matches. Here's what my graph looked like. The intersecting point is at 1, 3. So we're going to take 1 and 3, substitute it in for x and y. 4 times 1 is 4, minus 1 is 3. It works for our first one. Our second equation is negative x, so that would be negative 1 plus 4, and that is equal to 3. So again, we've graphed it correctly. Your steps. You want to graph the equations, and again, you can graph them however you want. You're going to find where the lines cross. Sorry. And your last step is going to be to check your answers. And when you check them, make sure you check them in both equations. A system of equations that has at least one solution is referred to as being consistent. If the system has only one solution, it's not only consistent, but it can be called independent. And that's what those prior three examples are. They only had one solution. They had one point where the lines crossed. So they are both independent and consistent. You can also have a system of equations that is consistent and dependent. And that means that it has an infinite number of solutions. When that happens, you're actually graphing the same line twice. The equations may look different depending on what form they're in. but when you graph them, you actually get the same line. And finally, we can have a system of equations that has no solutions, and that's called just inconsistent. And this will happen when we have parallel lines. So if you notice that the slopes are the same and your y-intercepts are different, you know your lines are going to be parallel and they're never going to cross. So those types of systems of equations are referred to as being inconsistent.